Welcome to the Chapter 2, Part 4 video. We started this in class by reviewing on our learning how to do scatter plots on our calculator. So I'm just going to quickly show you those slides so that you can remember what we did in class, the steps for how to put in information on your calculator using the lists as we did in class. And as a reminder, you can always watch the class recording if you wanted to go back and watch those steps more specifically. I'll also be doing an example or two here through the slideshow as well. So entering those lists tells your calculator what is the information that you want to graph. And then to graph it, you have to go into your y equals menu and turn plot 1 on, meaning you want it to be highlighted with the black box around it. And then you press graph, but make sure that you're looking at the appropriate window. So remember, we said in the standard view, we can only see the numbers between -10 to 10. So if my numbers are between those values, that's fine. I can leave it in that view, but sometimes we need to change the window. And then we have to remember, in order to graph a new equation, we'll have to change the window again. And then the second part of that, once we had our graph, our scatter plot on our calculator, then we wanted to be able to say, well, what's the line that goes through those points the best? What is the line of best fit or the linear regression? And so our second part here is to calculate. We went into our statistics menu and then we went over to calculate the linear regression. And then we said, and I want to store that information as my y1 equation. And so we stored it as the variable, the function y1. And then once we had all that information in there, we can calculate. Okay, so that's what we did in class. And then we tried it out with these tables. And then we also looked at how to clear the lists. We don't want to delete them, right? We just want to clear them. So let's talk about, this should be new information. Let's talk about why this is so important. So we talked about what a scatter plot is. It's a graph that has two sets of data and we can plot it onto a two-dimensional coordinate plane. So we have one set of data such as years, for example, and one set of data that could be, for example, money, right? And we can look at money over time. And that's why we wanted to look at this on a two-dimensional plane or a standard coordinate plane. And then we said, once we look at that data, then we can say whether or not it has a linear correlation. So once we're looking at that data, we'll be able to say what shape it has. Now, if that shape looks like a line, so if I were to circle all of my points on the first graph, that circle makes kind of a line shaped, right? I can draw a line through that information and we're all going to have almost the same line. It's always going to have a negative slope and it's always going to be right through the middle of that set of points. Now, that doesn't mean any of those points actually lie on the line. It just means that the line is really close to all of the points. So we say that because the line is close to all of those points, that is a strong correlation. Because that line would have a negative slope, it is a strong negative correlation. So this word negative refers to the slope. If we look at our next example, if I put a circle around that data, or if I encircle the data there, I can still see that it has a negative slope, but would I put my line here or maybe over here? Or maybe it would tilt a little bit more this way, right? There's a couple options I have for the line that would go through that information, those points. And so we can say, well, it still has a negative slope. No matter what line I draw through those points, it's gonna have a negative slope. So it still has a negative correlation, but there's too many options for how I could draw my line. So that is a weak negative correlation. There's a lot of options for how the line goes through those points. Now, on the calculator, it does some complex calculations called regression calculations, and it will give you the line that is the closest to as many points as possible. So it's finding the closest line to all of the points, okay? So we don't have to worry about what the process is for finding the line of best fit. The calculator will do that for us, but we should be able to identify if that line is going to be really close to the data points, if it's a strong correlation, or if it's going to be close but kind of spread out from the data points, that would be a weak correlation. On our next graph, we have here all of my points. If I kind of draw a circle around them, well, they're not decreasing. I can't say I would always draw the line this way with a negative slope, because maybe I draw it this way with a positive slope, or maybe, you know, the line of best fit is something like, I don't know what it's going to look like. It could look like anything, right? So this time we say it's not definitely having a negative slope. It's not definitely having a positive slope. I don't have any idea what the line of best fit would look like just from glancing at this data. So there is no correlation. Not all of our data sets are going to have a linear correlation. Okay, in our next graph, I can say, well, if I draw a circle around those points, it definitely has a positive slope. But again, there's a couple different choices that I have that I might visualize for the line of best fit. And so this is a weak correlation, because there is a correlation. I can say that it's an increasing correlation or a positive slope. However, I can't immediately tell you, oh, this is probably the line of best fit. I can say, well, it's going to be somewhere around one of these lines. And then our last example, all of those are pretty tightly grouped together. They look like they form a line, and I can have a pretty good idea of where that line would go. So that is a strong positive correlation. Okay, so strong versus weak is how close are those points to actually looking like a line. Positive and negative is talking about the slope. Okay, so all of these, we said, all of these look kind of like lines. I'm comparing them always to lines, but linear is not the only type of correlation we can have. If you'll think back to Algebra 1, we have this shape called a parabola, right, for x squared. If I had my data that looks like this, well, that's not a linear correlation, right? If I look at all of these data points, they don't form a line. They form kind of a U shape. And so I could say that that has a strong quadratic correlation. Okay, so linear correlation isn't the only type of correlation, but it's the only type that we're going to look at right now. Okay, so let's look at some data. In this example, we're looking at utilities. The table lists average monthly temperatures and electricity costs for a Texas home in 2008. The table displays the values rounded to the nearest whole number. Make a scatter plot, and how would you describe the correlation? So I'd like you to pause the video and try to do the scatter plot on your calculator, and then we'll run through it together. Okay, so I'm going to switch over to my graphing calculator. Let's see if that works. Okay, so I have the data table here on the left side of the screen. In order to tell my calculator that I want to evaluate this, I need to go into Stat, and then I'm going to edit my lists. Now, I already have my lists cleared, but if you don't, you'll go up to the list name and hit Clear, Enter, and that will clear your list. Okay, so I want to make temperatures are going to be my X values. Oops, here we go, X values. Let me use a different color. Temperatures are going to be my X values. Electricity will be my Y values. So this will be my list 1. I'm going to go ahead and type 61, enter. 58, just going down that list, 67, 75, 79, 83, 84, 85, 81, 76, 65, and 58. And then I go over to list 2, and I'm going to type the electricity bills. So that's 150, 139, 172, 205, 170, 234, 255, 245, 210, 183, 132, 110. And then a good way to check that you didn't miss any numbers is just to make sure your lists end at the same place. If one list is longer than the others, then you want to make sure you go back and you check for typos because something isn't right since our table has the same number of column or rows for each column. Okay, so our table is all typed in. What we do now, we want to graph it. So we go into y equals. I'm going to clear out the equation I had in there. I'm going to turn plot 1 on. Okay, now if you haven't used Scatterplot before, as we saw in class, this should help us graph it. But look at the numbers that we're graphing. These are not all between -10 and 10, right? If I find my smallest value in my x column, that's 58, and my biggest value in my x column is 85. And then I'm going to do the same thing in my y column. My smallest value, I see a 139. I see a 110. That's my smallest value. My biggest value is 234, 245. 245. So I just went through the column and I said, what's my smallest and what's my biggest number? And I want my window to be at least the smallest number and going up to at least the biggest number. So, and I like to round. So I'm going to make that from 50 to 90 in my X's. And then I'll make my Y's from 100 to 2, I'm going to make it 260 just so I have plenty of space. Okay, so how do I do that? Well, like we saw in class, we'll go into window. My X minimum, I said I want it to be 50. My X maximum, I chose to be 90. Don't change the X scale. My Y minimum is 100. My Y maximum is 260. Don't change anything else. And now I can graph. So there are my points. And if I'm looking at this, I can say, wow, that's a pretty strong positive correlation. They're grouped together nicely around where I can picture the line will be. Okay, so I would say that that is a strong positive correlation. All right, so let's head back to our slideshow here. I'm going to clear this off. So it's something like, you should have this on your calculator in front of you. It doesn't have to be perfect. It should just be enough information so that you can see, you can picture, why are we going to call this a strong positive correlation? So, and then in a different color, I'll do strong positive correlation. Each of these points corresponds to something from our table. Okay, so this point right here corresponds to December. This one is probably February, right? So each of these points corresponds to the coordinates of something in our table. Let's look at another example. So this time, the table shows the numbers of hours of students spent online the day before a test and the scores on the test. So we're going to make a scatter plot and we are going to then describe the correlation. I want you to try this. Okay, we are going to call this X and this Y. The first row or column is going to be X. The second row or column will be Y. So it'll be XY or XY when we're looking at these tables, just to make sure that we all end up with the same graph. Okay, I'm going to jump right to viewing the scatter plot on the calculator, and you can check if your calculator looks the same as my screen. The first thing I'm going to do is look at the window. So the window that I used, if we look at our table, right, our x's were between 0 and 5. So my smallest x was 0, my largest x was 5. And so I want my window to be at least 0 to 5. I like to put a little border, a little buffer room around my graph. So I decided from -1 to 6. The y values went from 60 to 100. So again, I'm going to give myself a little buffer room. And this time, so my smallest was 60, my largest was 100. So I'm going to give myself from 55 to 105. Okay, as long as you're not going from a number higher than 0, if you decided that you want your window to be from 0 to 5, that's okay. You'll be able to see everything. If you want your window to go from 60 to 100, that's okay. You will see everything. The problem with that is when you graph it on your window. Oh, what happened to my pen? There we go. On your window, there will be a point that is on the very edge of your window. Okay, I'll show you what that looks like. But first, let's see if our graphs look the same. There is my graph. So how would I describe this? Well, the points will make a pretty tight line. So I would call that a strong negative correlation. That would be a strong negative correlation. So let me show you what happens if I changed this from 0 to 5 and 60 to 100. What would happen? Well, when I graph it, notice I have points on the very edge of my screen. That's why I like to leave a little buffer room. So I highly recommend find your smallest, go a little bit smaller. Find your biggest, go a little bit bigger. So this line of correlation that we've been drawing is called a trend line. So remember how earlier I said we can have a linear correlation, we could also have a quadratic correlation. So when I have data, when I have a scatter plot that looks like a line, the line that I'm drawing in is called the trend line. It's the line of the trend of the points. What are they looking? What do they look like? What is the best fit? The reason in your calculator it's called a linreg, it's called a linear or line-shaped regression. And so it's finding the linear equation, y equals mx plus b, or ax plus b, as the calculator says, that fits between those points. So when I say a linear regression, a line of best fit, a trend line, they're all the same thing. So let's try this example. Now this one is a little bit trickier because we're not going to put into the calculator exactly the numbers that are given, okay? So let's read the question. The table shows the median home prices in Florida. What's the equation of a trend line that models a relationship between time and home prices? Use the equation to predict the median home price in 2020. Okay, so we can call year our X, we can call mean price our Y, we can type in all of these numbers into our calculator as our X values. Or because we're dealing with our calculator, right? We can decide that X is going to be the number of years since 1940. So what does that mean? That means our X's are a little bit different than the years, right? Because in 1940, how many years has it been since 1940? Well, in 2020, how many years has it been since 2020? It's been 0 years. So really, we're going to use an X value of 0. What does that do? Well, it does a couple of things. Really, all it's doing is shifting our graph. Okay, instead of being at 1940 for our starting point, we're going to make 0 our starting point. So it will change the window that we're looking at. Okay, it will also make the equation more manageable. It'll make slightly better numbers in our equation. Okay, now if you're looking at these median prices, those are really high prices. So we should still expect some big numbers in our equation. Okay. Okay, so for our year, in 1940, it's 0 years since 1940. How do we know how many years it's been since 1940 in 1950? Well, in 1950, to find out how long it's been since 1940, I would subtract 1940. And that would give me 10. If I was born in 1940, I would be 10 years older in 1950. Then how old would I be in 1960? That's 20. 1970 is 10 more years, so that's 30. 1980 is another 10 years, so that's 40. 1990 is another 10 years, so that's 50. 2000 would be 60. And I'm going to add in 2020, that's this year. So if you were born in 1940, how old would you be in 2020? Well, that's 20 years since 2000. So I can do it 2 ways. I can do 60 plus 20 to get 80, or I can do 2020 minus 1940, which will also give me 80. This way we have to borrow 0, 0, 80, right? Okay, and this is what we want. This is our big question mark. This last point that's not on our chart that we added in, right? We're looking for the answer in 2020. Do I have enough information to put that on my scatter plot? No, I only have the year. I don't have the median price, right? So that's not going to be a point on my scatter plot. I'm going to have a total of 1, 2, 3, 4, 5, 6, 7 points that we're typing into that list. So we're going to put this in our calculator. Again, I'm going to let you try putting it into the lists. And then we'll go over together. I'll confirm what window I'm using and we'll look at the scatter plot together. Okay, so let's take a look. Once you have your lists typed in, 0, 10, 20, 30, 40, 50, 60 for your X values, and then the prices for your Y values, we have to select our window, right? So let me clear this off. Okay, so again, I've got the table copied down at the bottom of the screen and we'll look at the calculator above it. So how did I select my window? Well, first thing I looked at is my smallest X value was 0. My largest X value that I'm plotting is 60. So I went a little bit below 0, which is -5, and a little bit above 60, I chose 65, and I made that my window. Make sure that when you're typing this, this is a negative. That's this button down by enter, not minus. If I put that as a -5, if I try to graph that, well, if I put a -5 and I try to graph that, it will give me a syntax error. What does that mean? Well, I can't, -5 is in the number, right? Minus needs something in front of it. So what's happening is if I go to the problem, if I hit 2 and I go to the problem, it'll say, hey, that's, what am I subtracting from, right? So within the calculator, there's a difference between minus and subtraction. And we have to make sure that we are subtracting only when there's something in front of it. 3 minus 5, okay. 0 minus 5, okay. Nothing minus 5, can't do it. So if there's nothing in front, then it has to be a negative sign. So we said our X values go from -5 to 65. Our Y values, my smallest Y value is 23,000. My largest Y value is 105,000. And therefore, my smallest Y value that I'm going to graph, something a little bit smaller than 23,000 is 20,000. So I chose Y values between 20,000 up to a little bit more than 105 is 110. So 20,000 to 110,000. So 20,000 to 110,000. And I'm actually going to erase this comma because it could be confusing. Is it 20 or is it 20,000? And then we're gonna go ahead and graph it. And you should have something that looks like this. When I'm looking at that, I can say that that has a very strong positive linear correlation, right? But that wasn't the question. The question, if we look back at the slide, the question is to find the equation, right? So how do I find the equation? Well, if I erase this, to find the equation, we have to do the linear regression. And so we're going to say stat, calculate. We want to calculate the linear regression. Calculate the linear regression, option 4, just like we did in class, using list 1 and list 2, that's my x's and my y's. And I want to store my equation as a variable. So we're gonna go down here, vars, y vars. I want to store it as an equation in my y equals menu. Specifically, it is a function, and we want to call it y1. Then we'll go down and hit calculate. Okay, so there it is, okay? Where a, because it's multiplied by x, that's my slope, b is still b. Why did we have to store it as a y variable? Because now when I go to graph this, I can see the line of the equation that I just drew. This is our slope. This is the y coordinate of our y-intercept. Okay, but we want to know what is the median home price in 2020. So we want to know what happens when x is 2020, the year, right? And we said that really that means our x value has to be 80. And if our x value is 80, then I want to substitute 80 for x. Okay, now when I switch back to my calculator, all of that's probably going to go away. So let's see what happens when we do it on the calculator. Yep, it's gone. Okay. So this is a benefit to having typed this into my y equals. There's a feature on the calculator that I can put a specific x value and get the y value. And that is the table of values. So we're gonna hit second, graph. Notice second is the blue button, and I'm gonna go to I want to select the blue writing. So second was like shift. And if I look at my table of values, -3 corresponds to a y value, 0, my y value, 2, when x is 2, this is my y value, right? I want an x value of 80, right? So if I wanted to click down all the way to 80, that would take a really long time. So here's a shortcut, okay? Notice above window, it says table set. So the window is where on the graph I'm looking. Right above that is where on the table I'm looking. So we're gonna go second, table set. Instead of starting the table at -3, yours probably started at 0. Instead of starting it at -3, we are going to start it at 80. Now this time we don't have to leave any buffer room because I'm just looking at a table of values. So we'll go second, table. Now it starts at 80, then this value right here is the price in 2020, okay? So that's $138,029. I'm going to try, so when x is 80, y equals 138,029. So that's the answer to the question. Use the equation to predict the median home price in 2020. That was our last example. I'm going to go ahead and clear off my notes here. Your homework for tonight is the lesson check. There are 4 problems. Make sure you turn in the PDF. It is not complete until you turn in the PDF. If you have any questions, shoot me an email and I'll get back to you as soon as I can.